Okay, today we're doing multiply polynomials, and if you remember from Algebra 1, we have some rules here. The first one is when you're multiplying polynomials, the bases have to be the same. So we call them bases must be like. Now, if the bases are alike, when we're multiplying them, we end up taking their exponents and adding them together. So for example, if we had x to the third times x squared, it would end up being x to the fifth. Because that's really 1, 2, 3 x's times 2 x's. And that's x to the fifth altogether. If we are dividing like bases, then we subtract their exponents. So an easy example would be something like x to the sixth over x squared. That answer would be x to the fourth. And if I were to write it out, that's because you have 1, 2, 3, 4, 5, 6 x's over 1, 2. 1 cancels out with the 1 on the bottom. This one cancels out with 1 on the bottom. And I'm left with 1, 2, 3, 4, x to the fourth. If we're taking an exponent and raising it to another exponent, then we actually multiply the exponents together. An example of that would be x to the third raised to the second. This means 2x to the thirds. So here's 1x to the third multiplied by another x to the third, and that brings us right back to this rule right here. Whereas if you're multiplying, you add the exponents together and get us x to the sixth. So instead of having to write all this out, I just multiply 3 times 2 and get 6. Now these rules should be pretty much a review from Algebra 1. Alright, so let's try some of these problems. First off right here, what you want to look at is that you have a monomial multiplied by a monomial. They're just asking us to multiply these together. 3 times 6 is 18. A times a squared is a cubed, because I add. This is really a 1 right there. And then this little old b has got nobody to multiply together with. So that's your final answer. Notice the second one's a little different. I have a monomial out front, but then this is called a binomial. There are two terms here, and the terms are separated by an addition sign. So we have to distribute, because this 3a has to get multiplied by the 6a squared b, and the 3a has to multiply to the 4a cubed. Now 3a times 6a squared b, we already know the answer. We just did it in the problem above. It's 18a cubed b. And, well, let's do this. 3 times 4 is 12. A times a cubed. Okay, when I'm multiplying, I add the exponents together, so that's a to the fourth. And that's it. There's nobody else to multiply. Now the last thing I would try and do is see, can I combine these two? Because it's asking me to add them together. It's saying take that first term and add it together. Let me change my pen here. Let's change it to a green. It's saying add these things together. Okay, a cubed can only get added to another a cubed. And that's negative fourth. So these are not like terms. So no, they are not like terms. So you cannot add these two things together. Right here, we have something that's a little different. We have a binomial being multiplied by a binomial. Now you probably heard of this last year, and they called it FOIL. I don't like the word FOIL. I like the word double distribution. And I'll show you why in the next problem. Up here, this was a single distribution. I only had one thing to distribute, the 3a. But here I have the 3a, which has to get distributed. And you can see by why now it's called double distribution, because then I have to go back and distribute the 2 also. Let's move this out of the way so I have some room here. Let's go back to my red pen and let's do the red distribution. 3a, 6a squared b, we know by now is 18a cubed b. The 3a times the 4a cubed, we know the answer is 12a to the 4th. But now we have to do the 2. 2 times 6a squared b is 12a squared b, and 2 times 4a cubed is 8a cubed. All right, so now, can we combine any like terms? A cubed. Do we see any other a cubes? Yeah, we do right here, but this has got a b attached with it. So this is really saying I have 18 a cubed b's, and don't have anybody else. A to the 4th, no other a to the 4ths. A squared, no other a squared. So this big thing is my final answer. Oops, okay. All right, sorry. Little problem there. We're back on track now. All right, so when we look at this, it's a double distribution because I have to distribute two things. I take the 2a and distribute it, but look how many times the 2a gets distributed. It's got to go to this trinomial, and that's why I don't like the word FOIL. Because if you didn't know how to do distribution, FOIL wouldn't work here. FOIL only involves first, outer, inner, last. And here I have first, outer, or inner, last, last, FOIL, inner. I got a lot to do. So let's do one at a time. Take the 2a, pass it out to each person in the trinomial. 2a times a squared is 2a cubed. 2a times negative 2a would be negative 4a squared. 2a times negative 2 would be negative 4a. All right, I still have more distribution to do. Let's take this 1 and distribute it. But distributing a 1 is kind of easy because I'm just multiplying everything by 1. And when you multiply everything by 1, it doesn't change. Now, this is going to get a little long here, but 1 times a squared is a squared. I'm going to write that right below the a squared. So now I know these are like terms and I line them up. 1 times negative 2a is negative 2a. Hey, there's an a, so this is negative 2a. Once again, like terms are lined up. 1 times negative 2 is negative 2. Now I have all my like terms together, so I can just combine. There's nobody to combine the 2a cubed with. Negative 4a squared plus a positive a squared makes it negative 3a squared. Negative 4, negative 2 means I have minus 6a altogether. And this minus 2 has nobody to hang out with. All right. Let's try this one. Immediately, I hope you see something that's different from questions 1, 2, 3, and 4. It's got a equal sign. So that means we're going to solve this equation. I was looking for my eraser, but I can't find it. All right, so let's just move from left to right. Let's distribute this y squared plus 2y. And the distribution ends right here because that's where the parentheses end. Now this negative 3 has to get distributed. And it stops right here because the parentheses stops there. So I get negative 3y minus 12. Y times y is y squared. And then we like this, y times 1 is plus y. All right, now I'm going to start moving things around. So I'm going to look, and the first thing I notice is that there's a y squared on the left side and a y squared on the right side. So if I minus y squared from both sides, I like it, the y squared cancels out. I'm left with 2y minus 3y minus 12 equals y. Hey, I like this right here. These are like terms. I can say 2y take away 3y is negative y. I still have the minus 12, and I still have the equals y. Just going to come over here for a little room. All right, now I got to get my y's together. So I'm going to take this y and move it over to the other side. Negative 12 equals 2y. All right, divide by 2, getting pretty easy here. Y is negative 6. And remember, you should always check your answers. Okay, last problem. Let's do this in red. This is saying cube. So you really have to think. That's your brain. And you really have to think that cube means to multiply by itself 3 times. So I really have a minus 3 times a minus 3 times a minus 3. That's the problem you have to do. All right, so let's write it out over here a little clearer. I have 1, 2, 3 of them. You can only multiply 2 at a time. So I'm going to take this first one and multiply it by the second one. I'm going to have to distribute. A times a is a squared. A times negative 3 is negative 3a. I'll distribute this. Negative 3a plus 9. I'm going to combine like terms. Now tomorrow in class I'm going to show you a shortcut on how to multiply a binomial by a binomial quickly. All right, so that's what I got when I multiplied these first two things together. I still have to take this and multiply it by a minus 3. Okay, let's start doing this. Let's distribute. A squared times a is a cubed. A squared times negative 3 is negative 3a squared. Negative 6a has to get distributed. Negative 6a times a is negative 6a squared. Negative 6a times negative 3 is a positive 18a. The last one. The 9 has to get distributed. So this was triple distribution. 9 times a is positive 9a. And 9 times 3, negative 3 is negative 27. Now let's see if we got anything to put together. Do we have any other a cubes? Nope. Do we have any other a squareds? Yep. In fact, we have negative 3 and negative 6, so that's negative 9 altogether. Do we have any other a's? Yes, we have 18 a's here and 9 a's here, so that's 27 a's altogether. And then the minus 27. And that is your big long answer.